All right, so chapter 5, part B. Let's look at, make sure we're recording here. All right, so part B, basic annuities. All right, so anytime you have a series of cash flows, and usually these cash flows are the same amount, not always, but usually they're the same amount, you have an annuity, these payments, okay? And so you see this many times, for instance, with loans. If you've ever gotten a car loan or a home loan, the payments are the same for the whole time you're paying on it, and it's usually monthly. Also, if you lease, those are payments that, well, at least as far as contractually, stay the same each month until they raise your rent. And so there's two types of annuities. Ordinary annuity, uh, the cash flows occur at the end of each period, whereas with an annuity due, the cash flow occurs at the beginning of each period. And so a good example of an ordinary annuity would be an installment note payable. It's payable usually at the end of each month. And so here we have an example of an installment note dated December 31, 2021, and these are annual payments. And the first payment's not due until a year later, December 31, 2022, and ending December 31, 2024. Whether it's end of year, end of month, it's basically the same idea though. Annuity due here, you're going to, the first payment's up front. Okay, so same example, 3-year lease beginning December 31, 2021, with the first lease payment being on December 31, 2021, and the last one being December 31, 2023. And of course, the lease ends December 31, 2024, so it's a prepayment. Now, again, just as with single amounts, you can figure out the future value. You can also figure out the present value. So here we're looking at the future value of an ordinary annuity. And so here the example is this Rita person wants to accumulate a sum of money to pay for graduate school, and she's going to start investing in a savings account paying 10% beginning 1 year from today. And the 10% is compounded annually. And so the question is, how much will she have at the end of year 3? Well, you've got two payments of $10,000 at the end of year 1 and end of year 2 that are going to earn compound interest of 10%. Now the payment of $10,000 at the end of year 3 is not going to earn any because it's not going to be in savings, but except for that one day. So it looks like this. You've got your first payment that's sitting there for 2 years, and then your second payment at the end of year 2 is sitting there for 1 year. So she'll have $33,100 at the end of year 3. Now, of course, if you go to the back of the book, and look at table 3, you find future value of an annuity, ordinary annuity of $1. And here, if you go to the 10% column and go down to period 3, you see that 3.3100. You could take that 10,000 and multiply by the 3.31 to come up with your 33,100. Now with an annuity due, the same example, your first payment is being paid up front, and so it's going to accrue interest, compound interest, annually for 3 years. Your second payment's going to earn interest for 2 years, and your last payment's going to accrue interest for 1 year. And so if you go to your table 4, you find future value of an annuity due, table 5. And if you go under the 10% column down on period 3, you find the number 3.6410. That's the number you would use to multiply times 10,000. Now, of course, you could work it the other way, figure out the present value of an ordinary annuity, how much you'd have to put in today to have some certain future amount. So here, same example, just a variation. She wants to accumulate a sum of money to pay for graduate school. She wants to invest a single amount today in savings account, earning 10% compound interest annually to the equivalent of what she would earn if she invested 10,000 at the end of the next 3 years. So essentially what they're saying here is she wants to have 33,100 at the end of 3 years. What does she have to put in today and have earn interest of 10% in order to have 33,100 at the end of 3 years? And so the answer is you go to table 4, go over to your 10% column down to number 3, third period, 2.48685 is the number, and you're going to multiply that times your 10,000 to come up with 24,868.50 if you want to get down to the exact number. And then, of course, for present value of an annuity due, here the payment's just going to be made up front. And so here you would simply go to, and so the question is, how much do I have to put in so that at the end of 3 years I have 36,410. So you would go to present value of an annuity due. That would be table 6. And if you go over to the 10% column, you have 2.73554. So you multiply that times 10,000 and you come up with $27,355.40. Now, of course, you can do all this on Excel, as we'll see here uh, shortly on the next round of uh, lecture. Last but not least, you can have a deferred annuity. Now, an example of this would be where you're going to receive a certain amount of money in some future date. So the first cash flow in a deferred annuity exists when the first cash flow occurs more than one period after the date the agreement begins. So this example here, payments aren't supposed to start until 12/31/23, but you're here at January 1, 2021 looking at acquiring this future investment that's going to pay you 3 equal payments of $10,000 each beginning December 31, 2023. And so here you're considering acquiring this investment to provide the 3 equal payments of $10,000 each. Time value of money is 10%. How much would you be willing to pay for your investment? And so here, what you're going to do is simply go to your present value of an ordinary annuity table, and if you look down at well, hold on. So here, what you're going to do is, well, there's a couple of different ways you can do this. One way is simply go to present value of 1 at 10% interest. Okay, so that would be table 2. And you would go to the 10% column and go down to period 3, 4, and 5, and you would simply multiply 10,000 times 0.75131 for year 3, 0.68301 for period 4, times 10,000, and then for period 5, 0.62092 times 10,000, and sum up those figures like they've done here on well, right here. Now you could do it another way. You could figure out the present value at the beginning of the annuity period of this amount, and then reduce it to a single amount calculated in present value as of today. So here the present value of the annuity, if you go to table 4, period 3 is 2.48685 at the beginning of the payment period. So you take the 10,000 and multiply it by that number, which equals 24,868. Then you're going to take that 24,868, and that's going to be your single figure, and then you're going to go to your present value of $1 table and multiply that number, 24,868, times 0.82645. Because those are the two periods that haven't been accounted for. And of course, nobody uses it anymore, financial calculators, but you could do this on a financial calculator. I find it cumbersome. Much easier to use Excel. So Excel has this present value calculation, and we'll talk about it next time. Now, of course, you can figure out other variables. If you know three of the four variables, you can figure out the other variable, just like we saw in part A. So here, assume you borrow $700 from a friend and intend to repay the amount in 4 equal installments beginning 1 year from today. Your friend wishes to be reimbursed for the time of money at 8% annual rate. What's the annual payment that must be made to repay? So payments are going to happen at the end of the period. So this is an ordinary annuity. So you've got 4 periods, $700 is the principal amount, and 8% is your annual rate. And so here you would simply take that information and what you're going to do is you're going to go to 8%. Well, you're going to go to your table 4, present value of an ordinary annuity. Under the 8% column, if you look down at the 4th year, you've got the number 3.31213. You would simply you would divide $700 into the 3.31213 to come up with $211.34. So that's your loan payment each period. So here they change it around, same example. Here same example, but variation. So you're borrowing $700 here, and you want to pay $100 in equal installment payments at 7% annual rate. So you're going to take and you're going to divide the 700 into the 100, 100 into the 700 to come up with 7.0. you know your interest rate is 7%. And so if you look down in the 7% column at year 10, you've got 7.02358. And so what this tells you is that your payments will be right around just under 10 years. All right, so here, suppose a friend asked to borrow $331 today and promised to repay you $100 at the end of each period for each of the next 4 years. What's the annual interest rate implicit in this agreement? So present value is $331. You're receiving $100 at the end of the period for 4 years. So again, you're going to divide 100 into 331 to come up with 3.31. If you look around here, if you look in table 4, present value of an ordinary annuity of 1, and go to the 8% column, you see 3.31213. So it's going to be right at about 8%. So what do you do when there are unequal cash flows? So here we have an example where you borrow $400. You promise to repay the loan by making 3 annual payments of $100 at the end of each of the next 3 years, plus a final payment of $200 at the end of year 4. What's the interest rate implicit in this agreement? Well, here you got to do a little bit more work. So you've got annuity for 3 years of 100, then a single payment at the end of year 4 of 200. And so you're going to take and do this. So basically what you have going on here is you have to figure out the present value of annuity of the annuity payments. So you're going to essentially trying to figure out what they're doing here. This one's not very clear. It is in the book. All right, so if you look in the book to page 257, you've got $400 present value equals $100 annuity amount times some figure plus $200. And so you have you have to figure out your present value of the annuity payments plus the present value of $1. The easy part is the the $200, that's, you would go to your present value of $1. Let's see. I'm trying to figure out how they did this. So it says one way to solve the problem is to trial and error the answer. For example, if we assumed it to be 9%, the total present value of the payments would be calculated as 100 times 2.53129, and then so that's in the present value of an annuity table, and then plus 200 times 0.70843, that's from the present value of one table, in which come up with $395. So it's somewhere between almost, well, the interest rate that you're looking for is somewhere between 9 and 10. Not a very good example. All right, let's go on. So some of the uses for this stuff, and most of it's going to be either present value of an annuity or present value of an annuity due. And so valuation of long-term bonds. With long-term bonds, if you recall, hopefully from your principal's days, what you have are interest payments twice a year, semi-annually, of a certain amount, certain percentage, and the face value of the bond is paid at the end of the period, the maturity date. So really what you have is an annuity payment twice a year for however long till maturity, and then you have a payment at the very end. So really what you have to do is figure out your present value of an annuity, the annuity payments plus the present value of $1. That's the payment at the end of the face value of the bond. So here we have an example of this company issuing a 10% bond with a face amount of $200 million. The bonds mature on June 30th, 2041, so 20 years from the date of issuance. The market rate of interest for similar issues was 12%. So in order to make this bond competitive, since the rate's only 10%, they're going to have to reduce the amount of the face amount of the bond to make to end up so that the buyers can end up receiving the equivalent of 12% interest on the payments, as well as the face value of the bond. So what you have going on here is you're going to have to figure out the present value of the annuity. So you take the $10 million. Here you're paying semi-annually the interest. Now notice that you don't use the stated rate of the bond, you use the market rate here. So here, since you're paying this semi-annually, it's going to be not 20 payments at 5% per payment. It's going to be 40 payments times 6%. So that comes up to 150,400 or 150,463,000, and then you have to figure out the present value of the 200 million lump sum, the face amount, that's going to be paid at the end of that 20-year period, that comes up to $19,444,000. So the price of the bond issue is less than the face amount. And again, they did that in order so that the bond would pay the equivalent of 12%, thus making it competitive. And so this is an example of a bond being issued at a discount. That happens when the stated interest is less than the market interest rates at the time of issuance. And so for the first payment of interest, the company is going to record interest expense using the face value, or excuse me, the book value of the bond issue, which after 6 months is going to be the 169,907. And so they take that and multiply that times 6% to come up with 10,194,420. Now, long-term leases are examples of present value of an annuity due. And so here we have a 25-year lease agreement. Terms of the lease call for this company to make annual lease payments of $10,000 at the beginning of each year, with the first payment to be made January 1, 2021. So they're simply going to take that $10,000 and since they're assuming an interest rate of 10%, reflecting the time value of money in this situation, they go to their tables or Excel, figure out what the present value of an annuity due for 25 years at 10% on $10,000 is, and it is $99,847. So essentially they're paying $250,000 over the lease period, but the present value of this annuity due is only $99,847, so they're paying a lot of interest. An installment note. So this is kind of a common example. Here, this company's purchasing a machine for $35,000. They put $5,000 down, and the $30,000 remaining balance is put on a 5-year installment note. The note calls for an annual installment payment at the beginning, with each payment due on January 1, 2021, and at each December 31 thereafter, assuming a rate of 4%, interest rate of 4%. What is the amount of the annual installment payments? So here, each payment's going to be $6,480. Now notice that this is again an installment note, but it's an annuity due since the first payment's up front. So first payment, they're going to make this entry here, the initial entry, and then right after that, since they're making their first payment on the date of purchase, they record this, and they're going to record this at the end of every year after this initial payment too. Now, note here that this initial payment has no interest component because no time has passed. You just purchased this machine on the date that you make your first note payment. Now on the second payment and thereafter, you're going to have interest expense. So here you've already reduced the amount of the note by 6,480. So 30,000 minus 6,480 is what? 23,520. So you take 23,520 times 4%, come up with $941 interest expense. Last but not least, you have valuation of pension obligations. This is going to be a case where you've got to do some work here. You're going to be making payments now into the future, and then at some point when this person retires, they'll be receiving monthly payments in equal installments. So Stridewell hires this person, Terry. Terry's expected to work for 25 years before retirement on December 31, 2045. So the date of hire is January 1, 2021. Annual retirement payments will be paid at the end of each year during his retirement period, expected to be 20 years. First payment will be on December 31, 2046. During 2021, Terry earned an annual retirement benefit estimated to be $2,000 per year. Company plans to contribute cash to a pension fund that will accumulate to an amount sufficient to pay Terry this benefit. Assuming that Stridewell anticipates earning 6% on all funds invested in the pension plan, how much would the company have to contribute at the end of 2021 to pay for pension benefits earned in 2021? Well, you got to do this in two steps. First step is you have to figure out the present value of the $2,000 annuity for 20 years. And so here you're simply going to go to, the interest rate assumed is 6% that they'll be earning on this stuff. The annuity payments, $2,000, and that the period of time they're going to pay this annuity once this guy retires is 20 years. So N equals 20, I equals 6%, and of course the annuity amount's 2,000. So again, you go to your tables. You've got this is present value of an annuity, ordinary annuity. So you look on here under 6% in 20 years, and you find the number 11.46992. So you multiply 2,000 times that number and come up with a present value of 22,940, and then you're going to take that 22,940. So that's going to be a present value of 1. So you're going to go to your present value of 1 table to figure out how much you're going to pay. Well, how much the present value is of essentially 24 payments at 6%. So that number So essentially what you've done is figure out the future value of the annuity. And so you take that future amount of 22,940 and you're going to go to your present value of 1 table. Here you're going to be paying this amount over 24 years before this guy retires. And you know the interest rate is 6%, so you go to that number, you look under table 2, 6% down to 24, and you have 0.24698. So you multiply the 22,940 times 0.24698 to come up with 5,666. That's the amount that the company is going to pay to contribute to his pension plan at the end of year 1. All right, I know that was a lot, but anyway, we'll go over this again, and you'll get a lot of work on this. All right, I'm going to do a Excel lecture tomorrow, and I will put that out there on the Canvas.